in the end, it's about the climate, and in order to minimize the emissions that we get with an electric car, even though sometimes electricity is still generated from fossil fuel sources, we have at least the opportunity to upgrade in the long term. So in the fundamentals, it's about the efficiency. If you take a fossil fuel burning car, you will always have local emissions in the car itself. While with an electric car, you won't have any emissions at the car, and only at the power plant that's still probably burning coal. And then in the future, we have the opportunity to upgrade it. So it's two things: it's climate, but it's also, if you look at the local part, it's also the air quality, of course. Our mission is to provide clean mobility for everyone. So we want to start with a product that's 100% clean from the start. And with any hybrid solution, you will still have the emissions of the internal combustion engine. So if we put that option next to our mission, it's not an option. It's a little bit hard to say. So the fundamental thing about the Lightyear 1 is efficiency. We make the car more efficient, and there's a couple of key technologies and key innovations that you need to do to make that car more efficient. So the three I usually pick out is the solar panel and the electronics behind the solar panel, the in-wheel motors, and the aerodynamics of the car. But in the end, it's how they all work together to make an efficient car. There's been a lot of research into what's limiting the adoption of EVs, because currently about 2% of sales is EVs, while about 50% of people indicate they are interested in driving an EV, and about 28% of people are interested in owning an EV as their next car. If you ask them why they're not buying one now, then we get the same arguments that we've been hearing for the past decades. And the three main ones are: first one, cost; second one, range. How far can I go on a single charge? And the third one is charging. So people are worried, how am I going to charge? Can I charge wherever I park? And so that's also the fundamental things we need to solve and focus on to get widespread adoption of EVs. Yeah, it's actually, so the car is designed to focus on exactly these three barriers. So what you see is that most of the EV companies currently are focusing on one or maybe two of the problems. So they either make a cheap car by getting lots of the batteries out, and then to make it cheaper, but then they lose out on range, or they put a lot of batteries in, so they get a lot of range, but then the car becomes more expensive and charging also becomes more difficult. You will charge slower because the efficiency of the car goes down. So what we try to do at Lightyear is find the one thing that makes all three of these better. So what makes both price better, charging better, and range better? And then in the end, it's about getting a lot of range out of a small battery, because a small battery will allow you to have low cost and relatively faster charging. And but then how do you get a lot of range out of it? And then you get to the key differentiator, which is efficiency. So if you make the car more efficient, if it's able to drive more kilometers on a single charge, that's when you get the smaller batteries, so lower cost, easier charging, and also a larger range. So efficiency is the key to solving the three main concerns that customers still have. To achieve the extremely low energy consumption of the Lightyear 1, you really have to look at the fundamentals of where the energy is going. So you start at the basics. What are the biggest factors contributing to the energy consumption? And in case of the Lightyear 1, and probably in the case of most EVs, but of course it will change a little bit. If you build a truck, it's a little bit different than for a car. But for the Lightyear 1, the biggest factors are aerodynamics first, then rolling resistance, and then the efficiency of the powertrain. So then you take these factors and you see, okay, how can I not just make them 10% better, but how can I halve them? And what do I have to do to achieve that? So the first one, aerodynamics, is mainly concerned with the exterior shape of the car. So you have to find out what's the limits on comfort. How do you how many space do you need for an efficient packaging of the person? How much space do we need for the solar cells? And then combine that with the aerodynamics knowledge and the design knowledge. So what the car will look like in the end. And we had a lot of focus on that optimization to get the exterior shape exactly to the point where it's very aerodynamic. There's a drag coefficient lower than 0.2, and still looking good and be able to fit a comfortable seating position, and also be able to fit the 5 square meters of solar cells. So that's the first one. Second one is rolling resistance, mainly influenced by the performance of the tires and the mass of the car. So you have to make the car lighter in everything you do, and you have to find the best tires in terms of rolling resistance that are still safe in the sense of how much grip they have, etc. And also actually the tires influence aerodynamics quite a bit, because the wider they are, the more frontal area the car will have. So it's aerodynamics again. And then the third one is the efficiency of the powertrain. So there also, you go one step deeper. Where do most of the losses go? So what we did in the Lightyear 1 is integrate 4 motors inside each wheel, which allows us to get rid of the drive shafts, the final drive, and a lot of other components that are usually causing additional mechanical losses in the drivetrain. I think it's a couple things. So first of all, solar panels are improving very, very fast. So we've been in solar car, we've been building solar cars since 2012. And in that time, so the first car we built, it had solar cells that were 22.3% efficient. And the last car that participated in the race in Australia from Eindhoven University had already cells that are 25.1% efficient. And those are based on the same procedure. It's all monocrystalline silicon. It's not expensive space cells or something like that. So in just a span of about 6 to 7 years, the efficiency has increased by 3 percentage points. And so that's one thing. Second is cost of solar has gone down ridiculously. And the third one, it has also taken quite some time, because car makers used to evaluate whether technology is suitable for their car by taking an existing car and testing if the technology would fit that proposition. And then usually it wouldn't. So if you look at what the traditional car makers are currently building in terms of solar cars, you have, for example, the Hyundai Sonata. And they promise about 800 miles a year of range from the solar panel. While with the Lightyear 1, we go 10x compared to that number under the same conditions. And that's because the Lightyear 1 was designed fundamentally as a solar car instead of as an electric car with a small solar panel on top of it. And that means, that factor 10 is basically built up out of about 2 to 3 times the area, higher efficient, half the energy consumption. And then if you combine all of that, you get to this factor 10. Yes, but you have to look at it in combination still with storage. And so the way we look at it is how much energy does your car consume over an entire year, and how much energy do you generate using a solar panel over an entire year. We will be able to match those two. We are already with the Lightyear 1 for most climates and conditions, so both for the Netherlands but also for California, that number is at about 70% today. The amount of miles that you drive annually versus the amount of miles that you get from the sun. We will be able to get that to 100% in the coming years. I don't think we'll be able to get to the point where no matter how you drive the car, if you go on very long trips every day, that you can get all of that from solar. And also you might still need to, so even if you get to the total same amount of energy consumption and yield over a year, you might still need to charge in the winter and deliver some energy back to the grid in the summer. No, actually it's not. Of course, there will be a difference in how much energy you get from the sun in different areas, but that doesn't mean that you have no added value in places where there's a lot less sunshine. So if we look at the Netherlands, for example, where you have indeed about half the amount of solar energy that you would get in California, you still get 70% of what the average person drives each year. So that's still a very significant amount of energy. And also, the biggest benefit fundamentally in the end is in the efficiency of the car. And that one you have everywhere you drive.